Saturn is the second largest planet in the solar system, but most people know it by its visible rings. Astronomers regularly observe the gas giant, and its properties help us better understand the structure of the cosmos. Saturn is now well studied, and anyone can get detailed information about it. Size, mass, and orbit. Saturn has an impressive size, with an equatorial diameter of 120,536 kilometers and a polar diameter of 108,728 kilometers. It has an area of 427*10 square meters, -1, and a volume of 827*1014 cubic meters. km. Interesting fact: Saturn's parameters exceed those of Earth by the following parameters: radius 9.3, surface area 82, volume 765, mass 95. The average distance of the gas giant from the Sun is 1.4 billion kilometers. When the planet revolves completely around the star, the maximum distance increases to 1,513,783,000 kilometers, and the minimum distance decreases to 1,353,500,000 kilometers. Saturn's rotational speed is 969 kilometers per second, but this can vary depending on its position in space. A year on the planet lasts 10,759 days, 5 times longer than on Earth. Composition and surface. Because Saturn is a gas giant, its surface density is low, only 0.687 grams per cubic meter, cm. It consists of molecular hydrogen in a vaporous state saturated with helium. An interesting fact is that because Saturn's surface has a low density, the planet will not sink into water if placed on top of it. Beneath the first layer, metallic hydrogen and helium have accumulated in the liquid state. The substance also contains impurities of volatiles, but scientists have not yet been able to determine their composition. At the center of Saturn is a solid core with a radius of 12,500 kilometers and a rough surface. It is heated to 11,700 degrees Celsius and may be close to Earth's composition. Under the influence of high temperatures, helium near the core heats up and gradually rises upward, moving to the upper layer. Thanks to this, the surface of the giant receives a large amount of energy, which is 2.5 times more than the Sun receives. Atmosphere and temperature. The main substance found in the upper layer of the planet is hydrogen. It makes up 96.3%, helium to 3.25%, and other substances only 0.45% of the total volume. Scientists have found that among the latter are phosphine, ethane, acetylene, ammonia, methane, and propane. Above the surface there is a layer of clouds, divided into an upper and a lower level. The former is filled with ammonium crystals, and closer to the surface is a mixture of water and ammonium bisulfide. Clouds are exposed to ultraviolet light, which causes photolysis of methane. This leads to the start of chemical reactions of hydrocarbons. The atmosphere consists of lines extending closer to the equator. It is also possible to divide into 2 floors. At the top, the pressure varies from 0.5 to 2 bars, and the temperature from -173 to -113 degrees Celsius. Generally, these vary between 10 and 20 bars and between -3 and 57 degrees Celsius. Between the layers is a layer of ice clouds. Changes in temperature and pressure occur in the same way. Occasionally, oval-shaped patches appear in Saturn's atmosphere that are whiter than other clouds. This makes them easily distinguishable on the surface. Scientists have not yet managed to explain their nature, but observations show that there is a pattern in the formation of spots. For example, when the summer solstice begins in the northern hemisphere of the gas giant, a large white spot appears in this area of the planet. There is a version according to which the formation of white patches is associated with electrostatic disturbances. Winds blow on the giant's surface with speeds that can reach 500 meters per second. It is the second largest in the solar system after Neptune. In the northern part of the planet appear currents with a wave structure, and in the southern part, jet. Fun fact: Saturn sometimes has storms that can reach Earth. One of the largest whirlpools, recorded by the Hubble telescope, was a hexagonal wind stream moving through the southern hemisphere. Its radius was 6,900 kilometers, and it made a complete revolution in 10 hours and 39 minutes. Saturn's structure studies have helped to show that Saturn is similar in structure to Jupiter and also consists of 3 layers. At its center is a rocky core. Its mass is estimated to be 10 to 20 times the mass of the Earth. It is surrounded on the outside by a layer of liquid metallic hydrogen about 14,500 kilometers thick. The top layer is 18,500 kilometers deep. It is made up almost entirely of molecular hydrogen. Because of Saturn's composition and the chemical reactions that occur there, Saturn emits large amounts of radiation into space. Scientists are still trying to figure out the reasons for the intense radiation. It is already known that inside the gas giant there is a Kelvin-Helmholtz reaction. Energy appears due to the large mass of the planet and the constant gravitational compression of such a massive matter. However, calculations show that this process is not yet capable of acting as a source of radiation in such quantities. This means that there are other processes occurring on Saturn that increase radiation. Heated helium streams are expected to be a source of additional radiation. Although Saturn's structure contains a solid core, most of the planet is composed of gas and has a low density. Orbit during a complete revolution around the Sun, the planet is on average 1.43 billion kilometers away from it. In comparison, Earth is 9.5 times closer to the star. Due to such an impressive distance, the planet completes a full revolution in 10,756 days. Interesting fact, it takes about 1 hour and 20 minutes for sunlight to reach Saturn. During this time, the planet travels a distance of 46,500 kilometers and orbits the star. The gas giant has the 3rd largest eccentricity in the solar system, second only to Mars and Mercury. This parameter indicates how much the track deviates from a circular shape. In fact, this is the difference between the maximum and minimum distance from the Sun. Saturn's eccentricity is approximately 154 million kilometers, which is 400 times the distance between the Earth and the Moon. The planet's axis of rotation is tilted by 26.73 degrees. Because of this, the planet's seasons change. However, since Saturn is very far from the Sun, the difference in seasons is not as noticeable. The planet rotates around its axis fairly quickly, second only to Jupiter. A day on Saturn lasts 10 hours and 45 minutes. Because of the high speed, the shape of the planet is not round, but spherical, with a noticeable thickening at the equator. The atmosphere and surface of the planet are divided into visible latitudes, which also rotate, but at different speeds. This is because Saturn's upper layer is made up of gases rather than solids. Saturn's rings. Saturn has the most conspicuous rings of any planet in the solar system. They are mostly composed of ice particles, space debris, and dust. This is why they can be seen so well even from a great distance. At the moment, 7 rings of the gas giant are known. For convenience at the time of discovery, they were named with the letters of the English alphabet: A, B, C, D, E, F, and G. If you look at Saturn in a telescope from Earth's surface, only A, B, and C are clearly visible. Studies have shown that the 7 rings consist of thousands of smaller rings stacked against each other. At the same time, there are distances between the groups. The greatest distance between tires and B, it is 4,700 kilometers. An interesting fact is that the nearest circle of Saturn is 7,000 kilometers away and the farthest is 73,000 kilometers away. Although the total width of the tires is about 66,000 kilometers, they are less than 1 kilometer thick. The formation of the rings. The main version of the formation of Saturn's rings is that they were formed as a result of the destruction of the celestial body. About 4 billion years ago, a satellite composed mostly of ice was orbiting around the gas giant. Due to unknown factors, it came too close to the surface of Saturn, as a result of which gravity broke it into small pieces. The latter did not leave the planet's orbit under the influence of gravity, but rotating around Saturn around its axis, gradually formed rings. The approach of the satellite to the surface of the giant is only one of the versions of its death. It may also have collided with another celestial body. There is an alternative hypothesis about the presence of rings. It says that they formed with Saturn from the solar nebula. However, in this case, the ice forming the rings should be covered with dust and other particles, but it is crystal clear. Supporters of the hypothesis believe that the lack of external dirt is due to the regular collision of rocks during the movement. Satellites of the planet Saturn. Saturn has 62 major satellites with certain characteristics and 9 celestial bodies not yet named. More than half have a radius of less than 5 kilometers. But in the orbit of the gas giant there are also large satellites, the size of which can reach 5,000 kilometers. Most of the celestial bodies are named in honor of the Titans of ancient Greece. Among them are a group of inner satellites located between the planet and the rings. 1. My mass. The egg-shaped satellite is only 185,539 kilometers from the planet. It has a radius of 198 kilometers and a mass of 410 kilograms. My mass takes about 22 Earth hours to complete a revolution around Saturn. 2. Targeting. A spherical moon with a radius of 252 kilometers and a mass of 110 kilograms. It is believed to be the smallest satellite in the solar system that revolves on its axis. Enceladus has occasional geologic activity causing cracks and geysers in the southern latitudes. Rising water proves the existence of an inner ocean where life may exist. 3. Tethys. The radius of the moon is 533 kilometers. Its surface consists of craters and plains. 5. God. It is considered the largest inner satellite of Saturn. It has a radius of 556 kilometers and a mass of 110 kilograms. The large number of craters on the surface indicates the great age of the object. All inner satellites are composed mostly of ice. They may also have a solid rocky core. The outer satellites lie outside the E-ring. Most of them are composed of rocks and ice. How many satellites does Saturn have? Observations show that Saturn may have as many as 150 satellites, but only 62 of them are in orbit. The others are located at great distances and are categorized as irregular. It takes them several years to make a complete revolution around the gas giant. Exploration history. Since Saturn can be seen without a telescope, it was discovered by ancient people. Mentions of the planet are found in Babylonian sources. The Greeks named the gas giant Kronos in honor of the god of agriculture, and Ptolemy was even able to calculate its orbit. In 1610, Galileo used a telescope to discover the rings around Saturn, but mistook them for satellites. Sometime later, Christian Huygens discovered Titan and several other celestial bodies orbiting Saturn. Until the 20th century, astronomers discovered new satellites. Interesting fact: Christian Huygens was the first to discover and describe the rings of Saturn in 1655. When humans began to conquer space, several airplanes were sent to Saturn. In 1979, the Pioneer 11 probe flew past the planet and photographed it. In 1980, Voyager 1 arrived, followed a year later by Voyager 2. In 2004, the Cassini spacecraft began collecting information about the planet and Titan, and 2 years later discovered a new ring. The gas giant is now regularly observed in modern telescopes. When was Saturn discovered? Humans discovered Saturn in ancient times. It is one of 5 planets that can be seen in the sky with the naked eye. The gas giant was known in ancient Greece, Rome, and Babylon. Who discovered it? Although people have been observing Saturn in the sky since ancient times, its discoverer can be considered Galileo Galilei, who studied the planet with a telescope he invented and saw it up close. How did Saturn get its name? The ancient Greeks named the planet Kronos after the god of agriculture. The Romans decided to borrow it and named the celestial body after its predator, Saturn. The gas giant has been called that ever since. Age: Saturn, like the other planets in the solar system, came into existence about 4.6 billion years ago. The hydrogen and helium in its composition suggests that the gas giant formed from a nebula. For the first 600 million years, the planet had no rings. Their research has shown them to be no older than 4 billion years old. How Saturn was born. At first, the solar system was replaced by a huge cloud of dust and gas. At some point, it began to be affected by an external force. It could have been a wave from a supernova explosion or a collision with another cloud. This caused the cluster to rotate and gradually shrink. The energy accumulated in the center caused the protostar that became the Sun in the future. The remaining dust and gas began to swirl around the star and became a disk. The harder materials were closer to the center, and that's where the Earth group planets formed. The icy particles and gases are far away. They formed gas giants, including Saturn. Life on Saturn is unlikely given the conditions here. Since the surface layer is made up of gas, it is impossible to be on the surface. In addition, temperatures here can drop as low as minus 150 degrees Celsius. As you move toward the planet's core, where the climate is warmer, the pressure begins to increase. At depth, where the temperature rises above zero, it is about the same as at the bottom of the world's oceans. However, there may be life on Saturn's satellites. On Titan, for example, there are hydrocarbon seas in which simple organisms can live. Telescope observations. Since Saturn can be seen in the sky with the naked eye, a telescope makes this task much easier. Even with amateur equipment, it is possible to get a large enough and clear enough image of the planet. You can find the gas giant in the southern sky. An interesting fact, because the rings also reflect light, the total visible surface area of the planet appears larger, making it easier to find. If you look at Saturn in a 60 to 70 millimeters telescope, you can see the rings and contours of Saturn. It is also possible to distinguish the colors of individual latitudes. For better detail, it is necessary to use fixtures with an aperture of at least 100 millimeters. Using a light filter doesn't hurt. Blue helps you see the rings more clearly. Green shows details of the poles, and orange helps you see Saturn's center better. How long is the flight to Saturn? The journey from Earth to Saturn takes a long time. Pioneer 11 reached it in 5 years, and Voyager 1 overcame this distance in 3 years and 2 months. Voyager 2 approached the giant in 4 years, while Cassini took 6 years and 9 months. The last spacecraft to visit the planet was the New Horizons. It took him 2 years and 4 months to accomplish it. Such a big difference in travel time is due to the different composition of the ships and the routes chosen. The constellation of the Big Dipper. The constellation of the Big Dipper is one of the most popular constellations. Due to the great brightness of the star, it can be found in the sky even with the naked eye. Already in ancient times it was a landmark for travelers, but now scientists have managed to study the cluster well. The Big Dipper regularly becomes an object of observation, thanks to which astronomers make interesting discoveries and better understand the structure of the cosmos. What the Big Dipper looks like, description and characteristics. The Big Dipper is the third largest constellation. The area of the cluster is 1279.66 square kilometers, which is more than 3% of the entire starry sky. It revolves around Polaris, thanks to which at all times of the year it is above the horizon and is clearly visible in the sky. The Big Dipper consists of 7 bright stars that together form the shape of a dome with a rod. In Latin, the constellation is called the Big Dipper, and its abbreviation is UMA. There are a large number of constellations in the vicinity of the cluster. This is not surprising given its impressive size. The list of neighbors includes a dragon, a giraffe, Veronica's hare, dogs, and both lions. Interesting fact, as Ottawa descends to the horizon in the fall, a legend spread among the Indians that in this way the animal prepares for hibernation. How to find Ottawa in the sky? Almost every constellation is quite difficult to find in the sky without special equipment. But thanks to the well-defined segment, finding Ottawa is not difficult. A person only needs to find this asterism and then the problem is solved. In late summer and early fall, the bucket is located in the northern part of the starry sky. For the best observation, it is recommended to wait until evening and leave the city, so that the light of houses and street lamps does not interfere with the light of the stars. Interesting fact, the north is easily determined by the position of the sun at noon. The star is now on the opposite side, in the south. In the fall, the asterism is located high in the night sky and is in a horizontal position. The stars that form it are so bright that the human eye immediately notices them, and the brain connects them to the objects sought by straight lines. As the Earth rotates around the sun and its axis, the position of the constellations visible from one point of the starry sky, little by little changes. Therefore, in January-February, Ottawa gradually turns in a circle. The bucket tilts when the handle is below the horizontal position, and the location of the cluster itself gradually shifts to the northeast. In the spring, Ka is the hardest to find in the starry sky. During this time, the asterism will eventually invert, so the uninitiated may not notice it. The Big Dipper is worst seen in northern Russia. The area often has white nights that make it impossible to see the stars. And if you look at the constellation of the central and southern bands, you should remember that the scoop under this view is placed with the handle up. The Big Dipper in the representation of the ancients. The Big Dipper is considered one of the oldest constellations, as it was mentioned by almost every civilization that lived on Earth. The first information about the cluster can be found in India, where people called it Saptarishi, 7 sages. The name comes from the 7 main stars that make up the chariot. The latter was also noticed by the Chinese, who even determined the time by its position in the sky. The Greeks came up with a beautiful legend describing Ottawa. It is known that Zeus often paid attention to beautiful girls. Kalisto, daughter of the king of Arcadia, was no exception. The wife of the god Hera learned about the plot and decided to take revenge. And so that the girl did not know the anger of the goddess, Zeus turned her into a bear and sent her to live in the sky, where she was completely safe. The Indians also saw a bear in this image, but according to them, the animal is made up of only 4 stars forming a trapezoid. And the handle of the ark depicts 3 hunters pursuing the beast. Elliot goes first and holds the bows, Mitzer carries the cauldron, and Bennett Nash Hospital brings a bush on his back arm to start a fire. Stars of the Big Dipper. The Big Dipper is made up of an impressive array of stars. But in his constellation, the bucket, there are only 7 lights forming a distinct shape. Thanks to modern technology, astronomers can constantly observe them and get the information they need. In addition to the 7 asterisms, the constellation contains about 125 stars. The human eye can only see 20 of them. Most notable are the 3 lights on the right side of the Dubmeric line. They form a triangle. In the lower right corner of the bucket is a similar figure consisting of bulbs, lambda, mu and psi. An interesting fact, in some cultures, the 2 triangles denote the hind and front paws of a bear. Also, several key stars are located to the right of the bucket, with only 2 luminaries hiding behind the horizon in Russia. And since in RF the constellation is always in the sky, by it local astronomers and stargazing people easily find the following objects. Asterisk Polaris, asterisk Cassiopeia, asterisk the constellation of Leo is nearby, asterisk the stars Capella and Arcturus, asterisk the constellation Gemini, asterisk the constellation Virgo. If you know which way these objects are located relative to the Big Dipper, you can easily find them. The variety of objects in the Big Dipper. Most of the objects of the Big Dipper are visible only in professional equipment. Only the Owl Nebula, labeled M97, can be seen in an amateur telescope. Next to it is the Starmer. Galaxies in that sector of the starry sky, where the Big Dipper is located. There are 1,500 galaxies of special interest to astronomers. And since the cluster is in the Milky Way, most of them can be seen in a professional telescope. The Cigar, Bode and Vertushka galaxies, designated M82, M81 and M101, are located at a distance of 12 million light-years from Earth. In addition, the former is considered one of the most beautiful objects in space, as its arms have a violet-blue luminescence, and the bright center is clearly defined and presented as a blue sphere. Superspiral galaxies have long, rounded tails surrounded by many bright objects. Astronomers compare them to fireworks because they resemble explosive fireworks. Next to the star Merrick is the galaxy M108. Its center is hidden by dust clouds. They also absorb light that is about 12 meters away when viewed from Earth. Thanks to Phaeton's nearby illumination, you can see a Milky Way galaxy called M109. It is considered one of the most difficult objects to detect because the star often dims. Tracking the position of the polar bear, astronomers regularly discover new galaxies with unique properties. Its convenient position in the sky allows you to see even the most distant objects. Big Dipper, the owl in the fall. Since all cosmic objects are in constant motion, the Big Dipper is located in a specific area of the starry sky at different times of the year. In the fall, most of the lights are hidden from the human eye. Asterism, however, is an exception. Its 7 main stars, although not as bright in September and November, can be seen with the naked eye. In the fall, the Big Dipper is in the north under Polaris, The bucket is turned by the handle to the west. The constellation of Pleiades can be seen in the east, with Aldebaran shining closest to it. In the northeast are the main luminaries that make up Gemini. But not all clusters are visible in the fall. Virgo and Leo cross the horizon in the Russian region, and the Eagle is barely visible from behind the Big Dipper in the western region. In the fall, the brightest constellations in the sky are the Big Dipper and the Big Dipper *1 Taurus *twin. These clusters can be seen at night without special equipment. To observe other objects, astronomers use professional telescopes powerful enough to zoom in on stars and galaxies of interest. For example, the Hubble telescope can observe more than 1,000 galaxies located in the star sector of the Big Dipper. This ensures that researchers will not have to take seasonal breaks and stop working. Myths about the origin of the Big Dipper. There are several legends about the formation of the constellation. The most interesting and popular is the Greek one. The girl Kalisto, daughter of King Arcadia, who was noticed by Zeus, has already been mentioned above. But there is another version of the myth. In his youth, Artemis often went to the forest to hunt, trying to find different game. In the assistant, he took exclusively beautiful young girls. Among them, Callisto possessed the brightest appearance. Her beauty attracted Zeus, and to win the favor of Callisto, the goddess passed herself off as Artemis. After some time, the girl gave birth to a son, Arcades. Zeus' wife Hera found out about her husband's deed and in anger turned Callisto into an ugly bear. Arcade grew up and became a hunter. And again the young man, who went out hunting, met his mother in the form of a bear. He did not recognize her and was about to shoot her with a bow, but Zeus intervened and turned them both into stars in the sky. Thus Callisto became Ursa, and Arcadius became Ursa. Since then they are always together in the starry sky, and because of the peculiarities of the place both clusters seem to look at each other. And when a man has found one constellation in the sky, he can easily find another. An interesting fact is that because the stars Benetnesh and Dub move in the opposite direction to the rest of the stars, the bull gradually changes shape over the course of the year. When is the best time to see Ottawa? To see Ottawa on the territory of the Russian Federation, it is necessary to go outside the city, so that the light of streetlights does not obscure the objects in the sky. The best time to observe the cluster is March-April. Interesting fact, in the first weeks of April, Muscovites can see Ottawa at its peak of prosperity. During these months, the Big Dipper rises to its peak, and every day around 23 o'clock the stars reach their maximum brightness. Raising his head, a person immediately finds a bucket, and if he has at least amateur binoculars, he will be able to see not only the 7 main stars, but also nearby objects. The worst time to visit Ottawa is in the fall. At this point, the asterism loses its brightness, and without a telescope to observe the neighboring stars associated with the constellation, you cannot do without it. Orienteering with the help of the Ottawa bucket. Ottawa from ancient times has been a reliable reference point for people due to its good brightness. Depending on the time of year, experienced trekkers can identify key points and move in the right direction. Most importantly, the Big Dipper helps you find Polaris in the sky. If you mentally draw a straight line from the lamp to the ground, then with the help of this cross you can accurately determine the bottom. Interesting fact, in ancient Russia, the constellation was called the horse because of its characteristic shape. Ice cubes were considered a stick to which an animal was tied. Once you know the location of north, you will immediately understand where the other directions are. South is behind, west is to the left, east is to the right. The stars Arcturus and Spica in the south help navigate through space. In the Middle Ages, sailors used them to pinpoint the correct course while on a boat in the middle of the night sky. The advantage of Ottawa as an attraction is that it occupies a large area in space. Even if observations are made in cloudy weather, there is a good chance that at least part of the cau will be visible in the sky. This is enough to identify the north location.